Okay, these are the notes for particle motion. Particle motion does not take up a unit in your textbook, so there's not going to be any work from your textbook through here. Particle motion has their problem every once in a while, and I sometimes use them, but this is the first time I've introduced particle motion to you because this is where it comes up in the AP curriculum for AP Classroom. So the videos explain some things about particle motion. It doesn't put everything into perspective. I'm going to do this graphically, and the reason they've not done it yet on AP Classroom is because you've not gotten the lesson on curve sketching. I usually teach curve sketching at the same time I'm teaching this, so some of this might be a little bit weird for you to look at, but I'm hoping that by explaining it graphically, when we do what we call curve sketching and analyzing graphs using derivatives and second derivatives, you will have a little bit stronger background to start with. So I've come up with this function, and these are screenshots from a TI Nspire. The TI Nspire is very useful in some instances, and doing it this way is very useful. So I've got this function, and it's going to be x of t equals x cubed minus 10x squared plus 21x. Oh, actually, if I'm using t, I need to put t's in there. So x of t equals t cubed minus 10t squared plus 21t. That gives me my position of a particle with respect to time. So in this graph, when I did this a while ago, I wanted to make this a position, a function that's moving right and left. So the increasing intervals on the graph are when the particle is moving to the right. If this was usually h of t, or if it was vertical motion, then it would be moving up. The decreasing intervals on this graph represent when the particle is moving to the left. If this was vertical motion, it would correspond to going down. So if we look at this, this function is going up or to the right from here to here. No, excuse me, here to here. I knew I'd said it wrong. So it's increasing from here to here. So I'm going to mark that in red. So for this graph, increasing is going to the right. Decreasing is when this particle is moving to the left. So this whole thing is decreasing. So in Algebra 2 and Math Analysis, you had to analyze graphs for increasing and decreasing. And this is why you had to do it, to understand when we got into calculus. So then the function's increasing again from here to here. The zeros, the x-intercepts on this graph, represent when a particle changes between positive and negative values of increasing, decreasing. Or no, let's go back again. The zeros represent when a particle crosses between positive and negative values of their position. So right here and right here. And I'll show you graphically. We're going to disregard this. Usually we talk about particle motion when time is greater than 0. We don't talk about it before 0. So let's go down here now. The AP Classroom does not show this aspect of it, at least not that I've seen. And this has helped me. So somebody taught me this way. This isn't t. This is going to be, this is x. This is going to be our position. So what happens At t equals 0, my position is 0. So when I start out, I'm right here. It's going to be moving to the right for 1.31 seconds, and its position is going to be 12.6. So right here, I'm going to make a point at 12.6. So this is particle is moving to the right. At t equals 1.31, or position 12.6, it's changing directions. That's what this means here. This maximum, relative maximum, when velocity is equal to 0, is it's changing its directions. Instead of moving right, it's going to start moving left. So I can't go back on it, so if you couldn't see it, I'm going to do this. Look at t equals 3. At t equals 3, it's going, the position is at 0 again. So right here, this is t equals 3. This is t equals 1.31. It's going to keep moving to the left until t equals 5.36, and its position is negative 20.7. So negative 20.7 goes to here. It's going to the left. This is at t equals 5.36. The derivative of this graph is the velocity. The velocity is 0. So velocity is negative, it's going left. Velocity is 0, it's going to change position. So I'm going to do it this way. And then it's going to go to the right. And it doesn't change directions again, it just keeps going. Well, right here, this was t equals 3. This is t equals 7. So at t equals 7, its position is at 0. So right here, this is t equals 7. And then it keeps going. I actually went to my table and I got it t equals 8. It was right here. But it still keeps going. This schematic helps me understand, and it helps me explain everything. So what I want you to remember from this is that this is going to be horizontal position as a function of time. And I did not give units for this. I could have easily. It could be that maybe we could talk about meters for the distance. So these would represent meters here. And as a function of time, I could have seconds, minutes, hours, however, whatever kind of particle we're talking about. So, and these are really just notes for me to explain it to you. So the particle is moving to the right from 0 to 1.31. That corresponds to the red here. Right here, the velocity is 0. So this is where it's changing direction. So it's changing directions, and now it's going to go to the left. It's going from the left from t equals 1.31 to 5.36. But this t equals 3 is the position. So that's where it crossed the origin again. So it's the origin here, here, and here. At 5.36, it changes direction, and it started moving to the right again. But at t equals 7, it crossed past the origin. Now I'm going to add another graph. Before I do, let me explain some things. So your velocity is going to be the derivative of your position. So my velocity for this graph is going to be 3x squared minus 20x plus 21. So this is my position. This is my velocity. position, velocity. And let's go back and color code again. So what happened, and remember, we don't care about left of 0. So this was going to the right. My velocity is positive. This is where it changes. So my velocity is greater than 0. Let's do it this way. So my position is increasing. So moving to the right. And velocity is greater than 0. Then what happened, remember, this is my position function. My position function is decreasing, so it moves to the left. All this section, it moved to the left to here. It corresponds to this section here. So then this is decreasing. So x of t is decreasing, moving to the left, and velocity is less than 0. Then this is the function here. It started moving to the right again, so this part of the graph is increasing. Corresponds to when the velocity is greater than 0. And there's not going to be a lot of practice right now with graphs. Later on there will be. So then the other concept that we look at is speed. Speed is going to equal the absolute value of the velocity. So let's add another color. If I talk about speed, so when you're driving, whether you're driving to school or you're riding with your parents or you're on the bus or whatever, when you're coming to school, you don't have a positive velocity and going home having a negative velocity. Well, you could, directional. But your speed isn't negative because then you'd be going backwards. So that doesn't make any sense. So when we're talking about speed on a velocity, speed is positive here, but it's got to stay positive. So when it gets to this, it's going to look like this. Speed will never drop below the x-axis. So my speed comes along here, it comes here, and it goes up there. That's a little bit more abstract to understand, but that's what speed does. Okay, hopefully haven't overwhelmed you. Now we're going to add acceleration to this. But we'll relate this all back together. So here's my position function. Here is my velocity function. Here's my acceleration function. So my position function, x of t equals t cubed minus 10t squared plus 21t. My velocity function, v of t, is equal to the derivative, so 3t squared minus 20t plus 21. And my acceleration function is my derivative of my velocity. So my acceleration function is going to be 6t minus 20. So acceleration of a particle is my derivative of my velocity and my second derivative of my position. Okay, so let's analyze this graph the same way we did the other one. And we'll talk about some different things. Okay, once again, we're going to ignore, we don't care about any of this at all. We are only going to look at t greater than 0. So this is my position function. Remember, this was moving to the right here because the function's increasing. So right here, my velocity is greater than 0. Now my acceleration, I guess we'll do light blue. My acceleration from here to here is that portion of the graph. So if I were to draw a line, that's what happens. So let's look at what I've got in notes. It says when the velocity and acceleration have the same sign, the particle's speed is increasing. When the velocity and acceleration have opposite signs, the particle speed is decreasing. So I've got my velocity is greater than 0. It's above the x-axis. My acceleration is below the x-axis. So from here to here, they have opposite signs. So I'm going to turn this around a little bit so I can write this neater. So velocity of t is greater than 0. Acceleration of t is less than 0. So speed, no, write it legibly. Is decreasing. And they talk about this in the AP videos, but they don't explain it graphically. So then what happened is this is my function is decreasing from here to here. It's going to the left. And from here to here, my velocity is less than 0. But what's happening right here, look at my acceleration. My acceleration changed from here to here. The acceleration is still negative here, and velocity is still positive. So, let's keep blue. So my position is decreasing. Here's my velocity is less than 0 from here to here. So what's happening, my velocity is below the x-axis, my acceleration is below the x-axis. That means they have the same side and the speed is increasing. So we turn this sideways again. Velocity of 0 is less than 0, or velocity of t is less than 0. Acceleration is still less than 0, so speed is increasing. If you don't grasp this concept from this notes, that's okay. I think the concept of speed is probably the hardest thing to understand from a graph. If you had values, it makes more sense, and we will do that. So then here, my velocity is still less than 0, but my acceleration is greater than 0. And right here, I'm going to draw these lines. Where velocity changes, so now my velocity is negative. My acceleration is now positive. So speed again is now decreasing. So when I look at it, turn it sideways again, my velocity is still less than 0, but my acceleration is greater than 0. So they're opposite signs, so speed is decreasing. And if you've taken physics, or if you're currently taking physics, you do talk about this in physics, just not in a calculus perspective. So now this is my position function moving to the right. This is increasing. So my velocity is greater than 0. And my acceleration is also greater than 0. So what's happening here is my speed is now increasing. And it keeps going forever. So velocity is greater than 0, acceleration is greater than 0, so speed is increasing. So it looks like a jumbled mess. So let's just recap for a second. Okay, so here's my particle motion. I'm moving to the right, left, and right. Increasing, decreasing, increasing. The concept of increasing, decreasing, you understood easily from math analysis, but now we're just applying it in calculus. Because now when we look at the second, or the first derivative, we're talking about velocity. So I started with a cubic function. The first derivative is this quadratic. Positive velocity, negative velocity, positive velocity. And then when we looked at acceleration, positive velocity, but negative acceleration, so that's why it's decreasing. Velocity is negative, acceleration is negative. All this is negative, all this is negative, so speed is increasing. Velocity is still negative, but acceleration is positive, so the speed is decreasing. Here, velocity started being positive again, acceleration is positive, so the speed is increasing. These points along the way that I've got marked are very important parts that we will talk about when we talk about graphs of derivatives. But that's for another day.